So we've talked about the area of parallelograms, rectangles, triangles, and we came up with two equations. All rectangles and parallelograms are the base times the height. Sometimes you hear length times width, but we're going to use base times height. And all triangles are 1/2 of its base times height. So let's draw a different shape. Let's do a trapezoid. And a trapezoid is a shape where you have one set of parallel lines like that. And there is an equation for a trapezoid. There's like a really just shortcut you can do for it, but let's break it up into sections. We could make a triangle here, and we could make a triangle here. And let's count those. Let's see. This base is going to be 1, 2, 3, 4, 5, 6, 7 units. We'll say it's feet, 7 feet. This top is 4 feet, and the height is 3 feet. We have this little section of 1 foot, and this section that's 2 feet. So the whole thing here is 7. Let me clarify that. There we go. So we have 3 sections. And this first one, this rectangle, is base times height. And so that's going to be 4 times 3, which is 12 units squared. Oh, I did feet. I don't need to put units. It's 12 feet squared. Probably better if I put feet here and here. I'm taking a little bit of a shortcut here. Let's find the area of this triangle. That's 1/2 base times height. And I'll put them in parentheses. I like the way that looks. So that's 1/2 of 2 for the base, 2 feet, times 3 feet. So that is my dog barking. And 2 times 3 is 6, times 1/2 is 3 feet squared. And lastly, we have this triangle, which is 1 foot by 3 feet. So we're going to do 1/2 base times height, 1 times 3. And that's going to give us, ran out of room, 1.5 feet squared, or 1 5/10 of a foot squared. Add it all together, 12 feet squared plus 3 feet squared plus 1.5 feet squared leaves us with 16.5 feet squared. And that is the area of this trapezoid. We just took this shape, broke it into smaller chunks. Let's do a kite. Kite is another shape that you might see that could be broken up very easily. So I'm going to just scroll a little bit. Let's move that to there. And we'll do kite here, 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 and here. And a kite is a shape where the adjacent sides are the same length. And we can take this shape and split it into 2 triangles or even 4 triangles. So we could split it like this and have a triangle on the left and triangle on the right. I said those backwards, left and right. We could split it like this and have a triangle on the top or bottom, or split it into 4 right triangles. And it's double the amount of work, but it can be a little bit easier to see. Again, there is an equation for this. There's an equation that you can do this kind of in one step, but for right now, I think it's a lot easier just to break it up, just to see how these pieces go together. So let's split it top and bottom. We have a base of 6, we're going to say to this time centimeters, and a height of 2 centimeters. So this triangle is 1/2 base times height, 1/2 of 6 times 2, which will, 6 times 2 is 12, times 1/2 is 6 centimeters squared. And this triangle, again, has a base of 6. We can just sort of flip that triangle around. And a height of 1, 2, 3, 4 centimeters. So 6 times 4 is 24, times 1/2 is 12 centimeters squared. Add these two together and we're left with 18 centimeters squared for the entire area of this kite. Again, there's other ways of doing this. There's multiple ways of decomposing or dissecting this kite into triangles. And there's no wrong way to do it as long as you're breaking into nice triangles and you're not going into some crazy convoluted way of doing it that doesn't need to happen. But these are how we break shapes into different pieces. We have a trapezoid up top, a kite here. They're just rectangles and triangles. Later on, we can get into much crazier shapes that could be broken up. But for now, we'll just leave it at this.